Hello everyone, Ismail is here. Today we're going to study 15.7 conditions of rectangles, rhombuses and squares. You know that you can find all the lessons on my website alfarab-math.com. Now here this is a warm-up question. Try to solve this warm-up question. It's easy to understand. Now let's go through the lessons. Okay, first let's start with this essential question. As you can see here, the essential question saying, how can we use given conditions to show that a quadrilateral is a rectangle or a rhombus or a square? Before we go through rhombus, rectangle and square, let me just remind you what something means. Rectangles, you know that it has, let's say, it's two sides, so it means this side here, okay, is congruent to this side here, and this side here is congruent to this side here. So as you can see, the opposite sides are congruent. Okay, the square, same thing here. It has four sides equal to each other. Means this one here is equal to this one here, is equal to this one here, is equal to this one here. Okay, just so if this one 5, this one is 5. This one should be example 2, this one should be 2. But the square, all of them should be example 4, 4 and 4. Okay, how about the rhombus shape look like? So the rhombus shape, it's same the square, except okay, these lengths, okay, this side here from here to here, and this side from here to here, they are just moved little bit to the right, like this. They are moved to the right, okay, and still the above line, same thing here. Okay, so the rhombus shape, it's like this one. Okay, it's same the rectangle, it's same the square, but as you can see, the sides go a little bit on the left, or it could also be go to the right. Okay, which means this one also can go to the right a little bit like this, go to the right like this, then you can complete your rectangle, your square, and it will be like this. And so the square or the rhombus can be in this side here to the right side, okay, and be like this. So as you can see here, the rhombus, okay, it should just lay on the right side or lay to the left side. So what do you think about the side will be? So if this one here still same as this one, which is 4, this one here is still same as this one 4, so what do you think about this side here and this side here? So both of them, they will be also 4, means this one here will be 4 and this one here will be 4, and same thing, this one 4, this one 4, this one should be 4, this one should be 4. So as you can see, rhombus, okay, and the square, they have equal side for all the 4 sides, but the rectangle is the only one which is different. Okay, now let's go to understand all of them together. Now the first thing, let's graph the rhombus. So the first step we need to do is plot the points. So plot these points to draw a line segment AB, BC, CD and DA. So AB, so -6 is here, then 4 should be here. So this one here is point A. Then B, 0, -4, 0, -4 should be here. Then we have C, 10 and -4. C is equal 10 and -4. Okay. Then 4 and 4, 4 and 4. So as you can see, this one here, so this one C is, this one is D. Okay, now if you connect between the points and you create your shape, so this shape here should be what? Rhombus. Okay, and I know that if I know one side, all the sides should be the same, right? So how can I know the distance using the distance from A to B? So the distance from A to B, just count the square. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10, okay, square. So the distance, the length here is 10. So for sure BC should equal what? 10. And for sure AB should equal what? Also it's equal 10. How about DC? Also should equal 10. Okay, how we can prove this one is 10 and 10? Okay, because maybe some of you teacher, okay, how can I count the steps diagonally? Okay, in rhombus and the square, you don't have to count them diagonally. If you count one straight side, all the sides should be equal to this one. But just to let you know, to prove this one is 10 and this one is 10, you can use, okay, distance, okay, distance formula. Okay, this, you don't have to know what is the formula exactly, but you just remember that you can use distance formula to find the length of the diagonal line. Okay, now let's start solving the question. So the first question, are both pair of opposite sides are parallel? Yes. So all both, this one here is opposite to this one, also this one here is opposite to this one. How we know this one? Okay, we can just measure, you can just measure, count the steps. Okay, measure, count the steps, right? Or I can do what? I can do what? Distance. Okay, distance, I will just write it short. Dist means is distance formula. Okay, formula. Okay, now question 2, what sides are congruent? Now what sides are congruent here? Oh, sorry, again, this one here, it's asking for the parallel line. Are the lines are parallel? Sorry. This answer here that I wrote should be for the second question. Yes, these are parallel because you can just say never, okay, never intersect. Okay, never intersect. Okay, that's why they are parallel. Now, what side are congruent, and how do we know? So all four sides, okay, all four sides are congruent. Okay, and how do I know? Okay, as I told you, we counting the steps, and we have what? Distance formula. So you can just say count steps. Okay, or I can say distance. Okay, I will just write dist, which is shortcut of distance, then formula. Okay, then question number 3, are both pairs of opposite angles congruent? Means is this one here, is this angle and this angle here, are both pair of opposite angles are congruent? So is angle D congruent to angle B? Yes, so B and D are congruent. Is angle C is congruent to angle A? Yes, they are congruent. Okay, so we can say this one, yes, they are congruent. Okay, because as we know that here, we can use the distance. Okay, using, okay, distance formula. Okay, or we can just say we know that the angles bisect, okay, each other. Okay, you can mention anyone. Now question number 4, do both diagonals bisect on each other? Yes, we just mentioned this one. The diagonals, as you can see here, this one is the diagonal from, let's say, from D to B, this one here in the green color. Okay, and on the purple color from C to A. Okay, so this two line bisect each other, means are they cutting each other from the half? Yes, they are cutting each other from the half. Okay, because we can use the midpoint formula. Okay, midpoint formula, or you can use, let's say, distance formula. Both of them will give you the correct answer. Okay, are the diagonals congruent? Okay, is the purple one, is this line, okay, from here, from C to A, is this one congruent to D and A? Are they equal? No, they are not. Okay, they are not congruent. No, they are not congruent. Why they are not congruent? Because as you can see, if we use the distance formula, AC, okay, it will be greater than BD. Using what? Using distance formula. Okay, now question 6, are the angles made by the diagonals, okay, are the angle made by the diagonals congruent? Means is this two angle, okay, means is this angle here congruent to this one here? Yes. Is this one here congruent to this one here? Yes. Is this one here congruent to this one here? Yes. Same thing here. Are they congruent? Yes. Why? You can say yes, because, okay, the angles bisect, okay, each other. Okay, so this is the rhombus, and this is what we learned about the rhombus. Now let's go okay, to the second shape. Let's start now with the rectangle. So as you can see, let's first draw the rectangle using the plot point, so using this point. So the first point is -5 and 1, -5 and 1 is here, so this one is point A. Point B is 3 and -5, 3 and -5 is here, so this one is B. Then C, 6 and 1, 6 and -1, okay. Then -2 and 5, -2 and 5 here. So this one here is D, this one is C. Now let's connect between the points. Okay, so as you can see here, I have a rectangle A, B, C, D. Now, are both, let's start solve the question. Are both opposite sides are parallel? Yes, they are parallel because they never, okay, they never intersect. Okay. Okay, then intersect. Now, are both pair of opposite sides are congruent? Okay, yes, they are congruent. Okay, because as you can see, if you count the steps, okay, from B to C, okay, will be the same as B to A. So this one is congruent to this one. And if you count the steps from D to C, okay, it should be congruent from A to B, right? But because this one is a diagonal, and I told you, using diagonals, we can't just count the steps because the square is not clear. So what we can use to find the steps, we can use distance formula. So yes, so by using, okay, distance, okay, distance formula. Okay, next, what angles are congruent and how do you know? So as you can see here, all the angles, okay, this one here is a right angle, this one here is a right angle, this one here is a right angle, this one here is a right angle. So all the four angles here are 90 degree, okay. Yes, they are congruent because all of them, because all the lines are perpendicular, okay, perpendicular line on from DC to CB to BA to AD. So all of them are congruent, okay. Okay, now question number 4. Do both diagonals bisect each other? Is this diagonal from D, okay, to B, is this one bisect from A to C or from C to A? Are they bisect each other? Yes, they are bisect each other, means this side here, okay, is equal to this side here, and this side here is equal to this side here. But let's read the question again. Do both diagonals bisect on each other? Yes, they are bisect on each other, but they are not perpendicular, okay. Yes, they are bisect, okay. And how do I know this one? Using the midpoint, okay, or we can use distance formula, okay. Now last question, are the diagonals congruent? How do you know? Now the diagonals, are they congruent? So is AC, okay, is congruent to DB? Yes, they are congruent. Why? Because you just say using, okay, same thing, using distance formula, because if they have same length, same distance, so for sure they will be what? They will be congruent. Okay, so this is about the rectangle. Now let's go to the last one, which is the square one. So as you can see, the square, just draw any random point. So as you can see, I will just draw this one here, I will put this one here, I put one here, and I will just make it small for to everyone understand what I'm talking about. So as you can see here, this one here, this one here, okay. Now this one is A, B, C, and D. Now as you can see, are both pair of opposite sides are congruent? Yes, they are congruent. Because because they never, okay, never intersect. Then what are congruent sides? So all four congruent. Okay, how do we know this one? Using distance formula, or I just can count what the step, because the steps here are straight. So 1, 2, 3. This one should be 3. This one should be 3. This one should be 3. So all the sides should be 3 using distance formula or counting the steps. What are the congruent angles and how do we know? So as you can see here, all the angles are congruent because all of the angles, yes, so all are congruent, okay, congruent because it's perpendicular lines, okay. Now, do both diagonals bisect on each other? Okay, is both diagonal from A to D is bisect on the C to B? Yes, they are bisect on each other. Okay, because you can just say that using the midpoint. Okay, or we can just say using the distance. Okay, distance formula. Now, question number 5. Are the diagonals congruent? Are the line from A to D is equal to the line from B to C? Yes, they are. Okay, using also same thing, distance formula. Okay, they are congruent using this one, because if you know the length of AD should be equal to BC. Okay, are the angles made diagonals congruent? So are the angles, which means he's talking about this angle here, is congruent to this one here? Yes. Is this one here is congruent to this one here? Yes. Is this one here congruent to this? Yes. So all the angles are congruent. Yes, all the angles are congruent because it's angle by, okay, bisector. Okay, so those are the 3 things that we learned, which is rhombus, rectangle, and square. And to summarize everything that we just learned, I just made a new table for you here to differentiate between them.